Well, welcome to Functions Lesson 1 in the C++ tutorial. Up until now, the lessons have mainly used the serial print to just display information to the serial monitor, and we've used that to learn to understand the basics of mathematics and different control structures. And now, finally, we're going to get to that bit where we turn the lights on, and quite literally, we're going to learn to use a digital pin and use digitalWrite to control that pin. Now, through this lesson, we're going to start to learn, first of all, what is a digital pin, and then what we will do is learn how to select a digital pin using pinMode and set it to be an output. We shall also start to use digitalWrite to turn the pin high and low. Again, it's that bit, what does that mean? Well, as part of this lesson, we'll learn to understand what high and low means, and also the ability to use alternatives to those words. And then to end the lesson, we will finish up using the built-in LED and improving on the blink sketch that you'll often hear about so often when people start to learn to use an Arduino. Very often the blink sketch is the first thing that people charge off to do, and you'll notice we've waited quite a time before we get to it. And hopefully as this lesson goes on, you'll start to understand why. So let's get straight into the IDE. So my IDE is started. I've already made sure that my Arduino is the correct one. I've got the correct COM port, and let's just start by loading the blink sketch and making some lights flash. So File, Examples, Basics, Blink. Bring up the sketch, and the code is only a few lines long, so let's get that compiled and uploaded to the Arduino. And hopefully by the time this is finished, you will have an LED that is flashing on your Arduino once a second. So it'll turn on for 1 second and then it will turn off for 1 second. So mine is now uploaded. My LED is flashing, and that's great, the lights are flashing, but realistically we've learnt nothing, and that's one of the dangers of just uploading somebody else's code. We haven't learnt anything. So what I'm going to do now is swap over the screen, and we're going to start to learn what is going on. So the first thing to learn is what on earth is a digital pin. Now if we look at this picture of a genuine Arduino, I'm just going to bring in a picture of a Chinese copy. As you can see, there's a slight difference in the board. This chip is different to the original, but realistically the digital pins, there are 14 of them. They start at pin 0 and they go up to pin 13. Now those 14 pins, although they're all digital pins, what we tend to do is only use pins 2 to 13, because these two end pins, if you see, they've got a TX and an RX, and they are used for serial communication. And bizarrely, if you start to use those, you'll actually start to see the output of them appearing on your serial monitor if you've got it open. So what are these pins? Well, realistically, a digital pin is a pin that can either receive digital information or send it. Now today we're going to be looking at digitalWrite, which is the method of sending data. So these pins, literally think of them as little on-off switches. Put very simply, if we turn one on, it will give 5 volts, and if we turn it off, it goes to 0 volts. Now that 5 volts isn't a particularly powerful 5 volts. It's certainly not going to turn a motor on, but what it allows us to do is turn on a motor driver board. So those of us who are doing the robot car tutorial, it's a way that we can turn a switch on that in turn turns the motors on. We could attach these to a relay that could then control a light. Even a mains voltage light could be controlled through it, and there is enough power that comes out of these certainly to control various electronic components and, more importantly, an LED, so we can make a light go on and off. Now, one of the joys of the Arduino that is a little bit of a help to us is, instead of having to build a circuit, this particular pin here, pin 13, actually has an LED attached to it. And on a genuine Arduino board, I'm pretty sure it's that little LED there that will flash. And if I bring my cheap Chinese copy version in, on my copy, the LED is this one with an L next to it. Now, just while we're looking at this board, sometimes when you're uploading your code, you will see the RX LED light and the TX LED light. That is when information is being sent to the Arduino or from the Arduino via the serial port, which happens when you upload a sketch to the Arduino. And of course on this one there's another LED up here on, well, it's to let you know the Arduino is attached. So the LEDs may be in a different order, they may be in different places, but they basically do the same thing. As we can see, the on LED on a genuine Arduino is down here. So our digital pins, the lesson that we're going to have today is about using those digital pins as an on-off switch, and the pin that we're going to concentrate on today is pin 13, so that we don't have to start adding components and building circuits. So let's switch back to the Arduino IDE and we'll get started. Right, we're back in the IDE, and just to let you know what I've done, I've taken the original Blink sketch and I've now saved it as Blink version 2. I've stripped out the header and put some different information in. Those of you who've been following the tutorial will know I have a way of writing my code, a specific way that I keep various versions, and what I tend to do is I use some code for the serial monitor, so that if any time I can plug in an Arduino and find out what sketch is actually on it. In fact, over the last few days that's been very useful for me. I've had a few identical Arduino Unos on my desk. I've been loading them with different sets of code, and now and again it's got to the point where I've thought, hang on, which sketch is on which Arduino? So by just plugging them in, opening the serial monitor, I can find out which Arduino is which is why I continue to have this sort of structure whenever I write a sketch. So the first thing you're going to see, if we look at the top, some of the things that we're going to do, we're going to be, first of all, we're going to be removing the use of a thing called LED built in. We're going to be learning to define a pin. We're going to understand pinMode. We're going to understand how digitalWrite works, and we're going to understand using high and low and its alternatives. Missed that bit out. Okay, so let's go down to the sketch, and basically below this line here is the original sketch, and what you'll see here is a thing called pinMode, LED built in, and output. Now if you remember, when we looked at our Arduino board, I mentioned that on pin 13 there is a built-in LED, and that LED is built in on various Arduino boards, but it is not always on pin 13. There's one or two boards where it is not on pin 13, but by using this function, whatever pin it's on, it will always light it. However, there is an issue, and it's why I don't like the use of this particular function. When you get good at programming, you may start to program other boards. You know, I program a thing called an ESP32 quite often, and this function doesn't work. because it's a different type of board. Now, when we're learning to program, ideally we want to learn to program in a way that our code works and can be swapped from one board to the other. Now, there's another issue that we have here. We know from what we've learned already that this happens to be pin 13, but we don't actually define anywhere that that is pin 13. And that can be dangerous because we can just use this, and don't get me wrong, the original Blink sketch is great if you just want to quickly test an Arduino's working. But going forwards, we need to write our code a little bit better, and LED built in will not help you when you're using all the other pins. So we're going to write our code today as if we were using any digital pin. So the first thing we need to do is define our pin. Now in this case, int, and we'll call it LED pin equals 13. So what have we declared here? Well, what I've basically said is that I have an integer. From those who've done the earlier lessons, you'll know an integer is a number that's under above minus 32,000 and change, and below 32,000 and change positive. So we've got an integer, we're going to give it the name LED pin, and we're going to give it the number 13 because pin 13 has a built-in LED. But of course, if we were controlling a motor driver board, this could be pin 8, pin 10, pin 2, it could be any number. And that's important for us to learn, that we tell the board which pin we're using. Now, one of the reasons I like doing it this way is that it actually starts to give me a list. And what I'll often do is up here in the header, I'll go pin 13 LED. So if I was writing a motor driver, I know it needs 4 pins. I would write sort of pin 8 to pin 12 motor drivers, just as a way of understanding how many pins have been used. Now you might think, crumbs, there's only 12 pins. How difficult can it be? Well, if we were using an Arduino Mega that has 54 digital pins. Now, if you're starting to use that many pins, and I've done projects where I'm well over 40 pins, you cannot remember what is on every pin and whether you've used a particular pin. So by keeping a list in the header, you know which pins you've used and which pins are still available. Now, before we've looked at using an integer, but this time we're going to change our integer. I'm going to just copy it. I'm going to paste it down here. And this time I'm going to put in front const. And we need to comment that out. And the reason we use this const is it means that this integer value cannot be changed. Now, if you think before, when we did our little lessons on mathematics, we could take an integer, we could have taken that value of 13 and we could have added something to it. Let's say we added 2 to it, it becomes 15. If you try adding to a constant integer, it will not work. So this is a way of saying this number 13 is always the value of LED pin. If we think back to one of the earlier lessons with the digital car park, it's almost like we have put our car in the parking spot and we put a clamp on it, and we're not going to allow that car out of the parking spot. We're not allowing anything else into the parking spot. It's a fixed number that will stay the same throughout the program, and obviously we don't want this value to change because we want this pin to always be the same. So we've defined our pin number. Now, instead of the original pinMode code, what we're going to do is we're going to copy this, we're going to paste it below, I'm going to comment that out, and what we do, instead of LED built in, we take our pin number and we paste that in instead. Now you'll notice it goes black. It's no longer the blue color. That's because it's a variable that is one of ours rather than a built-in function. So what that now does is exactly the same as the line above, except we're now using a pin that we have defined ourselves as pin 13. Now what we could have done, we could have avoided defining the pin. If we copy it again, I could have just written 13 in here. But of course that would work, but later on if I was starting to use 10 or 15 pins, I'm going to be completely lost as to what is going on. So using a named pin is the best way to go for the clarity of your code. So let's move on now to the main loop. So in the main loop we see a function, digitalWrite, LED built in, high, digitalWrite, LED built in, low. Now we're not using LED built in, we're using LED pin. So let's just copy that down and paste it in there, and paste that one in there as well. Now if you compiled this code and ran it, it will work and your LED will flash away just as it did before. But again, we're still not completely sure what is going on here. So let's start to explain the code. So pin mode. There are two modes that a pin can have. Okay, so a pin can be an input or an output. So if it's an input, it means it is receiving signals from outside. Someone externally is turning the switch on and off, and we are reading those on and off pulses. If it's an output, it is us using the pin as the on-off switch, so we are sending information out to other items. Now in this case we're going to be sending the information out, even though the LED is a built-in LED. Technically we're sending the information out because we're sending a signal to that built-in LED. So there are only two versions of pin mode. It is either an output or an input, and in this lesson we're going to be using it as an output and learning to use digitalWrite. In a later lesson we'll use it as an input and we'll see how we receive information. So let's go down to our loop, and as we can see, digitalWrite, so this says send some information to this pin. So our pin is pin 13, the LED pin, and what we're saying is send it high. So sending it high means we've turned on the pin, we're now sending 5 volts, and obviously for us the LED is going to light up. From earlier lessons you'll recognize delay, so we now wait around for 1 second, and then what we're going to do is we're going to digitalWrite again, and this time we're going to tell the LED pin that we want to go low. So in other words, the voltage now goes low, it becomes 0 volts, and the LED will turn off. And that, put very simply, is the basics of using a digital pin. Now what I'm going to do is we're going to keep that saved as version 2, and then what we're going to do is add some more code for version 3. Now turning on using these two words high and low is fine and is completely acceptable, but sometimes in my own programs I use a slightly different method, and I'm just going to explain that to you now. So let's think about what these what information this is actually sending. What this is saying is, if we just copy this out, put it down here, we could write this as pin 13, because we know that is what the pin is, and instead of low we could use the value 0. So low is always equals 0. However, we could then do the opposite with the high and paste it in there, so we keep the right flashing order. And again, we could write pin 13. I'm writing the numbers in. I would never advise you to write numbers in because it's extremely confusing. If you could imagine, if we were on that mega and we're up to pin 40 something, what on earth do all these pins mean? So use a name for the pin that describes what you're using that pin for. Now, high is a little bit more difficult to explain than low. Low is always 0. High is an integer that is not 0. So we could put in a 1, but so high is any integer not 0. So it could be -2, -200, +35, 64, makes no difference. So it's any value that's not 0. I know that might sound a little bit weird. I'm going to write a delay in here so we can see it work. Put another delay afterwards. And we'll just put a note here. Below is not a good way to write code. Okay, so it works, but it's not a great way to do it. Now what I'm going to do is, based on what we've done there, let's think about that value 1. We're saying here that 1 is on, so why don't we go up the top here? Do you remember we had our constant integer, LED pin equals 13. We could have another constant integer, and this one we could call it turn on. Okay, so turn on equals 1, and then underneath that again we can have turn off equals 0. Now sometimes that can make life a little bit more easy to understand, so I've got some code at the moment that I've been writing that controls various displays and electric motors and different sensors and different things. And so what I've done is, instead of keep using high and low, I actually use a value of turn on and turn off. And the reason I've had to do that is, in my code I've got one item that when the pin goes high it's turned on. I've got another item next to it that when I put the pin high turns itself off. I know that might sound weird, but it's just the way that the components that I've got it attached to are set up. So I actually found it easier to write variables like this that gave me a description of what I was actually doing. And we could make it even clearer here by, we could put turn on LED, turn off LED. We could then have some other values here that might be turn on motor, turn off motor. And we'll see that those doing the robot car will probably have some code like that later on. Now once we've got these variables, we can then take them down and we can write our code again, this time digitalWrite, and we'll use our good name LED pin, and we're going to turn on the LED. delay 500, and then we'll do exactly the same, copy and paste it down, except this time we're going to put turn off the LED. So now what we're saying is this LED is pin 13, and when I turn it on, I'm going to send a value of 1, which is equivalent to high. And when I want to turn the LED off, I send a value of 0, and that is the equivalent of low, and turns the LED off. Very, very simple bit of code, but it just shows you the different ways that you can turn these pins on and off. And when this compiles, what you'll actually get is the LED will be on for 1 second, then it's going to go off for 1 second, then it's going to go on for half a second, off for half a second, and then it's going to do half a second and half a second again. So this code is good. And this code. So I hope that's helped you to understand a little bit more about what is going on here. The main things to remember is we define our LED pin. So we're saying pin 13, or whichever number we're using. We're going to use different numbers as we go on, but pin 13 we know has the LED on it. So pin 13 is our LED pin. We then use pinMode in the setup area of our code to tell the Arduino that pin 13, our LED pin, we're going to be using it as an output. We're going to be using it as a switch that goes high or low, plus or minus, plus 5 volts or 0. And then in our loop, when digitalWrite sends the value high or 1, the LED will light up, and when we write it low, we're basically turning the power off and the LED turns off. So I hope that's been useful to you, and we'll just have a quick recap as we end. So in this lesson we've learnt how to use a digital pin using digitalWrite. We've learnt what pins on the Arduino are digital pins and the ones we should be using. And don't forget that lesson about pin 0 and 1. You don't really want to be using them unless you can help it. We've learnt to use pinMode to set the digital pin as an output, and we've also learnt to write that pin using digitalWrite and setting it high and low. And we've also seen how to use alternatives to high and low, where we've used a variable that we've passed instead. So I hope again this lesson's been useful to you, and for those doing the robot car, of course, we won't be turning on our LED as such. We should be using it to turn the motors on and off. So look forward to seeing you in the next lesson, and don't forget that bit at the bottom. Click the like and subscribe if it's been useful to you. Bye for now.